Hello. This video is for IXL Activity A1.K.1. It's titled Graph Inequalities. The 3-character code for this activity is H68. Now the question asks us to graph x is greater than 2. Well, first of all, the symbol here is greater than. Let's have a discussion about that. This is an inequality symbol. In the past, we worked with equations where we used an equal sign. Now we're using inequality symbols. So let's review what these symbols mean. If we have this symbol here, like an arrow facing the left, this means less than. If we had a number that was over here to the left of the symbol and one that was to the right, we would say that this number is less than that number. Or we could go ahead and let's say A and B. We would read this as A is less than B. The arrow to the right, we know this as greater than. So if we had an A and a B there, we would read that as A is greater than B. The arrow with like half of an equal sign is the way I like to think of it. And this lets me know that it could be equal to it or it could be less than. It's like mixing an equal sign together with a less than sign. So the arrow to the left with a line underneath it, or half of an equal symbol, we read that as less than or equal to. So if we had A over here and B over here, we would read this as A is less than or equal to B. And then finally, the greater than symbol with half of an equal sign. This is greater than or equal to. So if we had the A and the B here, we would read this as A is greater than or equal to B. Now you'll notice in the directions here it says plot the endpoints. That means plotting, means we're going to select that point on the number line. Select an endpoint to change it from closed to open. Now we need to talk about closed and open. And then select the middle of the segment, ray, or line to delete it. So in my table here, I have this idea, or this concept of open and closed. You'll notice that whenever A is less than B or A is greater than B, and we do not have the half of an equal sign there, then we're going to use an open dot here. That means that the value of A is not included. So we want to show that A is not included because it can't be equal to it. However, if in the event that A can be less than or equal to B, or A is greater than or equal to B, this means that A certainly can be a solution, the value of whatever A is. So whenever we graph it, we want to show that we're including that point by using what is known as a closed point here, or closed endpoint. So with that in mind, let's go ahead and start graphing these. So it says that x is greater than 2. So first we're going to find 2 on our number line. So let's locate 2. It's right here. I'm going to go ahead and put an open point on it for now. Now I need to determine, should this be an open point or should it be a closed point? Well, we can see from our table that whenever it's less than or greater than, we're going to use an open symbol. So this is a greater than, so I'm going to leave that open. And now we know that x is greater than 2. Well, on a number line, everything to the right of 2 is greater than 2. So we're going to go ahead, shade that, and I got my line, yep. And so I would shade all of this here, including the arrow down here. And on IXL, the way that you do this is you would first click 2 once to get an open point, and then if you want it closed, you would then click it again, and that would close the point. And then after you determine open or closed, the next step is to click the arrow down here, and that'll fill in everything on this to the right of 2 on the number line. So in this process here, I would locate 2, click it once. Since I want it open, I'm going to leave it open. Then I want everything to the right of 2 because that would be all the values that are greater than 2. So I'd go all the way down here to the arrow and click on the arrow, and then IXL is going to fill the arrow in all the way along there, leaving the arrow highlighted, representing that even numbers that are greater than 9 are also part of the solution. Maybe that's something we should discuss. That graphing the inequality, what it does is it gives us a visual representation of all the possible solutions for this inequality of x is greater than 2. Any number that we pick that's highlighted here would be a true statement. 5 is greater than 2, 9's greater than 2, and somewhere to the right, way down here, is 1,279,394.6 is way down here someplace, and that number as well is greater than 2. So in review, we're going to find the point, plot it, consider which sign it is, go ahead and graph that, and also we have to determine whether it's open or closed. Now, one thing I want to point out on this, there's a helpful clue here. If you always make sure that your variable is on the left and that your number value is on the right, variable to the left of the inequality symbol, value to the right of the inequality symbol, then the arrow will always match, the arrow on your graph will always match this arrow looking symbol, or the arrow appearance that the greater than or less than, or the less than or equal to, or the greater than or equal to symbol makes. So put your variables on the left, plot your point, follow the arrow, and remember, determine whether it's supposed to be open or closed. And we'll look at some more of those in a moment. So here we are at the next question. It says x is less than 3. Well, my variable is indeed on the left, so I'm going to be able to use that little trick that I was talking about. So first step is, number one, let's go ahead and locate 3 on the number line. Here's 3 here, so I'm going to go ahead and click here and put my first point. I notice that it is x is less than 3, so since it is less than, and there's no equality concept with the half of an equal sign, I know that 3 cannot be part of the solution. And then notice that the arrow's pointing to the left. So if I make my arrow go to the left here, if I click down here on the arrow down here on the far left, click that, and let IXL fill that arrow in, is that going to create a true representation on the graph? Well, I can check that, pick any number that's there, -4. What if x were -4? -4 is less than 3. Is this a true statement? Indeed it is. So my arrow must certainly be going in the correct direction. On the next one here, I have x is less than or equal to -44. So something's changed. I'm now using the less than or equal to, so -44 could be part of the solution, so we probably want to use a closed dot. So let's go ahead and look at that. Find -44 on the number line. It's right here. I'm going to click once. I do realize that it could be equal to 44 because it's less than or equal to, so 44 is part of that solution. So I'm going to go ahead and click it a second time and fill that in. Then I'm going to click on that arrow down there at the end on the left. And notice again that since my variable is on the left-hand side of the inequality symbol, the symbol itself gives me a hint of which way to make my arrow go. Take a number and test it out. -47. -47 is less than or equal to -44. Indeed, -47 is less than -44, so my arrow is going in the correct direction. On the next one, let's go ahead and find that point. First step, find the point, 668. And here's 668 right here. And it is greater than or equal to, so 668 can be a solution. 668 is one of the solutions to it. And notice that the arrow is pointing to the right. So I'm going to go ahead and click over here on the arrow to the right on that end of the graph there. IXL is going to fill that in. And now my graph says that 668 and any number greater than 668 are the solutions to this inequality. And indeed, 668 could be it, right? If I substituted that in, let me get rid of that there. I substitute 668 in, and I say is greater than or equal to 668. Is that a true statement? Indeed it is, because 668 is equal to 668. And we are saying that the value of x can be greater than or equal to 668. On the next one, let's go ahead and find the point, 950. So here's 950 here. Click once. Is it open or closed? Does not have the equality concept there. It has to be greater than 950, so 950 is not part of the solution. And our arrow is pointing to the right, so if we make our arrow here point to the right as well, this is a true statement. Think of any number greater than 950, say 960. 960 is greater than 950. That is a true statement, so our arrow is going the correct direction. Next one, find the point. You're like, are they really this easy, Mr. T? Indeed, they are. So we're going to find our point, click it once. There's 640. Should we click it again for a closed circle? No, we should not. It has no equality concept, and we're talking about all the numbers that are less than 640. So all the numbers that are less than 640 on the number line are to the left, and indeed our little symbol up here, less than symbol, looks like an arrow pointing to the left to let us know which way to send our line on the graph. Here we are at this one here, so negative 34. Find it, click it once for the point. Now should we click it again for a closed circle? Indeed we should. Notice the is greater than or equal to, so since negative 34 can be a correct value to make that statement true, it is included. And now notice that the greater than sign looks like an arrow point to the right. If we go ahead and click down here on the arrow on the right down here, it's going to fill all that in. And if we check it out, test it out, say negative 20, negative 20 is greater than or equal to negative 34. That is indeed true. And plus our close point, negative 34. Negative 34 is greater than or equal to negative 34. Well, negative 34 is equal to negative 34, so negative 34 works as well. Let's go ahead and find negative 500. Click once, open point. Should we click again for close point? Indeed we should. We have the is less than or equal to, so the equality concept is there, so we'll go ahead and fill that in. And we want all the values that are less than or equal to negative 500. So all the numbers that are less than negative 500 are to the left of it on the number line. So we'll click this arrow down here. That'll fill all of that in. And again, we have our solution. Final question, x is greater than or equal to 0. So let's find 0 on the number line. Click it once to get our open point. Should we click it a second time? Hopefully you're saying yes, we should, because notice it does have the half and equal sign. So greater than or equal to, so 0 is indeed equal to 0, so we'll include that point. And then we're going to go ahead and look for all the values greater than 0. On a number line, everything to the right of 0 is greater than 0. So we'll click that arrow, it'll fill that in there, and indeed, we're good to go. So not too difficult of an activity. Basically, remember that you're going to first plot your point, then you're going to determine should it be open or closed. If it does not have the half of an equal sign there, if you don't see this like half an equal sign with the symbol, then we're going to leave it open dot. If the half of an equal sign is there, then we're going to make it a closed dot. And then we'll go ahead, and it's not very mathematically accurate to say make your line go the same direction as the arrow. But remember, if in the event that your variable is on the left side of the inequality symbol and your number value is on the right, that your arrow is going to go in the same direction that the inequality statement is pointing in. All right, so that concludes all of my examples for IXL Activity A1.K.1 Graph Inequalities. Good luck with your activity.